Gentlemen, welcome to another fun episode of Fun with Finance. Today we're going to be looking at annuities. Annuities are either present or future values of a series of money flows. What you'll need for this lesson again will be a pen or pencil, a notepad, a calculator, and the formula sheet. I will give you links for all of those as you've seen in the previous lessons. First of all, let's start with the definition of an annuity. An annuity is a number of equal payments made at regular intervals for a certain amount of time. An annuity is also subject to an interest rate. If any of the payments change, or if the interval changes, or if the amount you want to pay changes, or if the interest rate changes, you have to start a brand new annuity. The deal has to be the deal. So in the beginning, when the question is set up, if nothing changes, you can use one formula. If anything changes, you must use another formula. So there are two types of annuities. On the left-hand side, you can see that we've got present value annuities. And present value annuities are regular payments or installments that are made to pay back a loan or a bond over a given time period. The reducing balance of the loan is usually charged an interest rate at a certain amount of time. So, normal present values would be things like you own a car, you're using the car, you pay off the car. Or you live in a house, you're paying off the house. You have a loan from the bank to go overseas, you've gone overseas, you pay back the bank. So usually what happens in this one is who has the asset, I suppose, is the question. And the question is who has the asset? And for present values, you have the asset. You've already used it and you're now going to pay back the money, as they would shout. For future value annuities, they're regular equal deposits that are made into a savings account or an investment account, and they're going to provide for something in the future. The amount accumulates interest as you have it stored. So this would be things like you're saving up to go on holiday, or you're putting money away into your retirement fund, or you are, stockpiling something. The question when we ask who has the asset is not you. You're only going to get the asset. The asset that you have currently is a financial asset. You haven't saved up for the car yet, or you haven't saved up for the house yet. You haven't saved up for the overseas holiday yet. So none of it has been realized. So future value is still to happen, and the present value usually has happened. So you have the car already, or you live in the house already, or you've gone on the holiday already. This is the easiest way to kind of ask yourself what's happening when you see a question in a test paper. Who has it? If they don't use the words present or future, ask yourself who has it. If you have it, it's present value. If you don't have it, it's future value. So in all of today's lessons, we are dealing with future values, which means you do not have the thing you want yet. Question example 1. At the end of each year for 4 years, I deposit 500 Rand into an investment account. If the interest rate on the account is 10% per annum, determine the value of my interest after 4 years. Well, this is actually what you've seen before. You know that we're going to deal with these basic inputs of money, 1 plus I to the n. But what we realize here is that I've got a whole lot of these happening. So this is right now, this is in 1 year's time, this is in 2 years' time, 3 years' time, and 4 years' time. And each time I put in money, 500 Rand, 500 Rand, 500 Rand, 500 Rand, this entire system is subject to an interest rate. And we were told that that interest rate is 10% compounded annually. So compounded annually. But what you also know is that this is quite a lot of admin to calculate, because if you added these up and you wanted to work out what this was all worth at the end. Now the end is an important time frame. The end is going to happen here. This is at the end. So if you were going to move your money through time, the first 500 Rand, which I'm going to try and make blue, the first 500 Rand, this 500 Rand, would have to grow at 3 compoundings of your 10%, because it has to go 1, 2, 3 places. Your second one would have to grow at 2 compoundings, and it's going to go 1, 2. Your third one, let's go back to white, let's go red actually. Your third one is going to be 500 growing once, because it goes from here to here. And your last one has no interest growing on itself. This last one effectively is just going to be 500, 1 plus 0.1 to the 0. Now what you notice is if for you to do 4 different equations would be cumbersome, especially if you're going to deal with things that have 240 of the same payments. But what I do hope that you notice is that there's a common factor in all of this. There's a common factor of the 500 in all of them, and there's a common factor of this bracket in all of them. And the bracket happens to be growing at the same contents, and the power is the only thing that's different. So that would mean that if you could take this and you put it into your calculator, the total amount that you've accumulated at the end, so the final value of all of these is 2,320 Rand and 50 cents. And that's all very well and good. But there must be a quicker way for us to manipulate all these common types of parts to the equation. Okay, so let's take the number we saw earlier, which was the wrong color, which was the 2,320 Rand and 50 cents. That was made up of the 500 Rand that moved nowhere. It was made up of the 500 Rand that had to move 1 time frame, a 500 Rand that had to move 2 time frames, and a 500 Rand running out of space here, trust me, that had to move 3 time frames. If we look at these numbers though, this number which was 500, this number which was 550, this number which was 605, and this number which was the 66550. What I want you to look at is the fact that there's a lot of hidden information in these numbers. It is much better to be looking at this row of numbers, because in this row of numbers, what you notice is the only thing that changes from here to here is I've multiplied by an extra 1 plus 0.1. And the same thing here, and the same thing here. You've seen this before. In number patterns, in sequences and series, what we notice here is that you've got a common ratio. And the common ratio that we have here is 1 plus 0.1. If we have a common ratio, what we know then is that we could use the concept of having this formula, which is 1 minus r to the n over 1 minus r, and that's if r is a fraction, or we could have s of n is equal to a rn minus 1 over r minus 1 if r was positive. Well, what we can see is that this fraction here, this ratio, this number inside this bracket is going to be bigger than 1. So we are dealing with this formula for the sum of a geometric series. That means we can do the following. We can take this piece of information that since the ratio is greater than 1, we know we've got a geometric sum formula. We know that the amount we're going to invest is equal to A, and we know that our rate is equal to our interest rate. We would then be able to say that if our interest rate is 1 plus I, if I sub these values in to this formula, it would be the following. It would be that the future value of an annuity is made up of X. It is made up of what goes into R, power n minus 1, all over 1 minus I minus 1. And in the denominator, what you'll notice is that these brackets will fall away, and all we will be left with is the following. 1 plus I to the n minus 1 all over I. This is the future value annuity formula. You don't need to derive it every time. You can just use this. So if you don't have the asset and you're trying to find out what the sum of a series of payments is, we're going to use the future value annuity.
Just a moment. Okay, I found this on the web through.
Sorry, my Siri was listening to me. I hope you're all having a good laugh. Okay, so if this is the formula that we can use to find out pieces, the pieces we can find out is how much do we accumulate, what did we invest consecutively, what was our interest rate in 2 places, and what is n. In matric mathematics, the only thing we can ask you to find is a f, an x, or an n. We can't ask you to find I because it sits in two places on the formula. So if we were going to try solve for x, let's do some algebra. If we were going to solve for x, we would take the formula and we would say f multiplied by the denominator I was equal to x into 1 plus I power n minus 1. I can detach the x from its bracket by dividing, so I would have f times I over the brackets 1 plus I to the n minus 1 is equal to x. So we could manipulate this formula to try and find out how much we were paying monthly, daily, weekly, whatever the situation might be. These are going to be useful skills, algebraic skills that you need to have. You can see also that one of the skills you need to have is how to solve for n. Let me do that algebraically also. Let us solve for n in this equation. So we're going to solve for n. Again, we would cross multiply both sides by I, and we would get x brackets 1 plus I to the n minus 1. We would now divide by x to break its bond. We would add 1 to both sides. And oopsie-daisy, and then what we would do is convert from exponential form to log form. We did this in our last set of exercises. So we know therefore that n is equal to the log of the interest and the quotient that we've created on the other side. You would never have to learn this formula off by heart, but please make sure that you're able to do this in a test or exam. Let us do a couple of examples. Example 1, calculating a future value. Caesar decides to start saving money for the future. At the end of each month, she deposits 900 Rand into an account at the bank, which earns 8.25% compounded monthly. Determine the balance in her account. Let's first put down what we know. We know that she is putting in 900 Rand per month. We know that her interest rate, as a percentage in decimal form, is 0.0825, and we're also told that it is monthly, so I'm dividing by 12. We know that the time frame that she said is 29 years. So 29 multiplied by 12 gives us 348 months. That would mean then, if we take our future value equation and we write out what we're going to use, we would be able to sub into this equation and find a solution. 900 into 1 plus 0.0825 over 12 to the 348
1
minus
plus
1.
82 plus 5 over 12 is about...
I'm sorry, my Siri keeps listening to me. 0.0825 over 12. Make sure you punch this all into your calculator with the right brackets, and what you should get is 1289665.06. Then the 1.2 million. In this situation, we want to try to find out how much did Caesar deposit into her account over 29 years. So this excludes interest. So total deposits will be equal to the amount she's depositing multiplied by how many she's made. So 12 months and 29 years. Multiply all those out, 313,200, which is a lot less with interest. So 313,000 was total deposits. This question now is trying to ask you, how much interest did she earn? Well, total interest is equal to the difference between the final amount and the deposits. We know that the final amount of her account was 1289665.06, and her deposits, as we just saw, was 313,200, which means that interest that she earned was 976,465 Rand and 6 cents, 3 times as much interest as what she deposited. Let's look at this worked example. Cosma is planning a trip to Canada to visit her friend in 2 years' time. She makes an itinerary for herself and she expects the cost will be 25,000 Rand. How much must she save at the end of every month if her savings account earns interest at 10.7% per annum? So we know the final value in this case is 25,000. We know that interest is equal to 0.107 over 12, And we now also know how long she's going to be doing this for. 2 years' time for 12 months makes it 24 months. That means that if we're going to take f of x, 1 plus I to the n minus 1 all over I, we're trying to work out how much she's going to pay for x. Pause this video and try solve for x yourself. I hope you've given this a try. Let us rewrite the formula and make x the subject. First things first. F multiplied by I equals x into 1 plus I to the n minus 1. Therefore, x is going to be equal to f times I all over 1 plus I to the n minus 1. We plug in all our variables into our calculator, and what we find is that she would have had to have saved 938 Rand and 80 cents. Let's look at this example. Simon starts to save for his investment or his retirement. He opens an investment account and immediately deposits 800 Rand. This is the first time we've seen this word immediately, and it's important that we make a note of how we're going to deal with this. Immediately means something has happened right now. The account is going to earn 12.5% compounded monthly. Thereafter, 800 Rand deposits for each month for 20 years. What is the value of his retirement savings at the end of 20 years? Again, what do we know? We know that he's saving 800 Rand. We know that the interest rate in decimal form is 12.5% per month. But now what we know is that there was an immediate payment. That's the one. And then we know that there were 20 years and 12 months, which gives us 241 months. This is how we have dealt with the immediate. We have included an extra payment right now as it happened. This means, therefore, that his future value still belongs to this formula, 1 plus I to the n minus 1 all over I. We have 800 going into 1 plus 0.125 over 12 with 241 of these payments over the interest rate, 125 over 12. And so he has managed to accumulate 856,415 and 66 cents. Another concept that you must know for future values is the concept of a sinking fund. Vehicles, equipment, or machinery and other similar assets all depreciate in value as a result of their usage and age. Businesses often set aside money for replacing this outdated equipment or old vehicles in accounts called sinking funds. Regular deposits and sometimes lump sums are made, so when this is accumulated, they can purchase a new vehicle. The example would be as follows. You have a car now, and over time it depreciates. You have a future value of this car, which is lower than its buying value. The same car now, if you were going to buy it, there's inflation. So that new car to replace the old car has gone up in value. What you want to do is figure out that if your expected new car, if we could subtract how much you could trade in for your old car, the difference between these two would be what you would have to save inside a sinking fund. It is a way for companies and people to put away money for a future use. That's why we use the future value formula. Let us look at this three-part question on sinking funds, all with the same information. Wellington Courier Company buys a delivery truck for 296,000 Rand. The value of the truck depreciates on a reducing balance at 18% per annum. The company plans to replace this truck in 7 years' time and they expect the price of a new truck to increase annually by 9%. Calculate the book value of the delivery truck in 7 years' time. The new word that you may have seen here now is book value. Book value is the future value of an asset after depreciation. Pause this video and give it a try yourself. Calculate the book value of the delivery truck in 7 years' time. I hope you've given it a try. What we know is that the present value of this delivery truck is 296,000. We know that the interest rate for the reducing balance method is 18%, and we know that we're going to do this for 7 years. That means that the book value, the future value of this, will be equal to 1 minus I to the n. So 296,000 depreciating at 18% for 7 years means that the book value, the value after all of depreciation has happened, is 73,788 Rand and 50 cents. Same scenario, now they want you to determine the minimum balance of the sinking fund that you must have in order for the company to afford a new truck in 7 years' time. Pause this video and give it a try yourself. Well, what do we know? We know that the present value of the current truck is 296,000. We know that new trucks are going to increase in value at 9% with inflation. And we know this is going to happen in 7 years' time. So the future value of a truck to replace your current one will have to follow this formula. That means 296,000 has to grow at 9% for 7 years, which means that a new truck should cost you 541,099 Rand and 58 cents. However, what we know is that the sinking fund that we have to work with will be the difference between the new truck and the book value of the old truck, which means we're going to have 541,099 Rand and 58 cents, and from that we're going to subtract our 73,788 Rand and 50 cents from earlier, which means our sinking fund will need to accumulate 467 Rand 311 and 8 cents. And so now finally, in the three-part series, how much would our monthly deposits have to be so that we could replace this truck if the sinking fund earns 13% per annum compounded monthly? Pause this video and give it a try yourself. Well, what do we know? We know that the sinking fund, as we saw on the previous screen, would have to accumulate 467,311 Rand and 8 cents. We know that the interest rate is 13% monthly, and we know that we're going to have to do this monthly for 7 years, which means we got 84 months. If we take our formula, F equals X into 1 plus I power N minus 1 all over I, and now we want to work out the monthly deposits, we have to solve for X. So by algebra, we could say that F multiplied by I all over brackets 1 plus I to the N minus 1. When you sub all of these variables in from the left-hand side, we find that the monthly is 3,438 Rand and 77 cents per month. I hope you've enjoyed this video on future value annuities. Annuities themselves are split into either future or present. The next topic we will do will be present value annuities. From here, you're going to go do a formative assessment on future value annuities and sinking funds. Enjoy.